This video is for section 2.3. The target for today is students will be able to identify the extrema and zeros of a polynomial graphically and algebraically. Vocabulary. Extrema are the maximum and minimum points on a polynomial. Note that before this section we were talking about specifically quadratics. Now we're talking about all polynomials, so you will have or could have more than one maximum or minimum point. Example, identify the extrema of the function x to the third minus 9x squared plus 4. You need to look at the graph. In order to identify the extrema of the function, we look at the graph and we look for the maximum and minimum points. Notice, we can see here there's a maximum point there and a minimum point here. So looking at the graph, we see a maximum occurs at 0, 4 and the minimum occurs at 1, 1. And that is how you need to write your answer. Maximum at 0, 4, minimum at 1, 1. To identify the zeros of a polynomial are the x-intercepts, or points where the graph crosses the x-axis. Note we want to specifically look at x-intercepts. Two methods for finding the zeros. Obviously, like we just did, we can look at the graph, but we can also identify them from factored form of the function. If we identify the zeros by looking at the graph, you'll notice we have a 0 here, and a 0 here, and a 0 here. And so we state that x equals 0 at x equals negative 2. We have a 0 at x equals 1, and a 0 at x equals 3. So by looking at the graph, the x-intercepts we see are at negative 2, 1, and 3. Next are two student examples. You're going to want to graph the function and locate all extrema and zeros. So by looking at the graph, you need to find the maximum and minimums as well as the zeros for these two functions. You should pause the video now and try the two student examples. Now you should check your answers. Make sure that you zoom in and out on your graph so that you see all maximum and minimums and are able to find those points. Moving on, identify the zeros algebraically. If you're given a function in factored form, what you can do is you set each of the factors equal to 0 and solve for x. That will give you the zeros of the function. So in this case, I take x minus 3 equals 0, x plus 2 equals 0, and x minus 9 equals 0. And I solve my function. If I add 3 to both sides, x equals 3. Over here I find x to equal negative 2, and here x equals 9. And those are the zeros of this function. Next example, notice that not all of them have x by themselves. So, when we go to set equal to 0, in some cases, there's a little more work that has to be done to solve the equation. But you're going to solve it algebraically, just like you normally would. And I get x equals negative 1. Here I got to add 2. And divide by 3. And I get x equals 2/3. Finally, take away 10. Divide by 5. And I get x equals negative 2. And those are my zeros of this function. Notice this is for when the function is given in factored form. It's not given in factored form. You have to put it in factored form. Now you should pause the video and identify the zeros of the polynomial on your own. When you're finished, restart the video and check your answers. Here, when you check your answers, make sure you have the same zeros as I do. Remember, we set each factor equal to 0 and we solve for x. Notice in this example, our equation is not given in factored form. Therefore, we must factor the equation. Now, at this point, we would show you on the calculator how to use it to factor the equation. Doing so, you're going to get the following factors. I get x minus 7 times x plus 1 times x plus 2. And that's this function in factored form. Like I said, we will show you in class how to use your calculator in order to factor the equation. Setting everything equal to 0 and solving now, I should get x equals 7, negative 1, and negative 2. Once I get the equation in factored form, it's exactly like the previous examples. Here's another example to try. This example, using our calculator, results in x minus 2 times 2x minus 3 times 4x minus 7. Notice that in this case, not all of them have just x, so you do have to set it equal to 0 and solve. When I do this, I should end up with x equals 2, x equals 3 halves, and x equals 7 over 4. Once you solve your equation, check your answers. Here are two student examples for you. Now I would pause the video, work out the student examples, and come back and check your answers. Checking your answers, you should get the following for each example. If you did not get this, make sure that you entered the function in your calculator correctly, and then make sure when you set each factor equal to 0 and solve that you did that correctly. That is it for today. Please note the homework assignment and the wide range of problems.